So I'm really happy to be here because JFAL was the start of my whole speaking journey. So a couple years ago, or in 19, I had my first session at JFAL, and it was Ignite, where the slides just go like that. It was funny because I thought it's easy to start with Ignite because it's only 5 minutes. And then when it was accepted, people saying like, yeah, I've been a speaker for 10 years, but I've never brave enough to do an Ignite, so proud of you. And I was like, no one told me that. But yeah, that's how it all started here in JFAL, and I'm really to be back now with a full session. And it's good news that you want to learn something about design patterns. But before we go into that, I'll do this annoying thing. I have an important question. Who of you has never been to the supermarket? Okay, that's good news, because in this talk it's quite important that you understand how a supermarket works. So we have that off the table. Sorry. And then the topic of today is design patterns. So first of all, let's see what are design patterns. And there's lots of definitions and explanations online, but this is what I made up with some combined. And I think important thing first is design patterns don't give you code. So they're not about literal lines of code, and you cannot just copy-paste the design pattern in your application. So you might be confused, like, not about code. Why are we using them in software? So of course, in the end, you will create code based on them, but it's more like concepts on how to solve something than literal code. So design patterns provide you reusable general solutions for common problems in software design. Because I think a lot of you will think that your application is unique. I'm sorry, it's not. And a lot of the parts in there are also not unique. But the good thing is, so are the problems. So a lot of the problems we face in software are also not unique. And because a lot of people have those problems, people made solutions for them, and it's appeared that a lot of those solutions work good in certain problems. So if you have a common problem, there might also be a solution that works. And those solutions are now the design patterns. So you can see design patterns as blueprints on how to solve something. And those blueprints you can customize. So you can implement them that they fit your application. But the design patterns describes like a certain way of looking to a problem and a structure on how to solve something. So, if this is what design patterns are, but how did we get them? How did we end up with the names? How did we end up with the descriptions? And therefore, we need a little bit of history, because in 1994, 4 men wrote a book. They're the Gang of Four, also called. And in this book, they described design patterns. So they were coding for a while, and they've also found that there were certain solutions that worked in a lot of cases. And they decided to describe them. So you might be thinking, 1994, that's a long time ago, or at least for some of you it will feel like a really long time ago. And why would we learn them today? So yes, maybe some of them are less relevant because we have a different style of coding now. But a lot of them are so generic that they're still really relevant today. And it's good to learn them. So there are 23 design patterns in the book. We're not going to discuss all of them today, we don't have the time. But then at least you know they're there and you can learn about them if you want to. And they are divided in 3 categories. So structural, behavioral, and creational, thank you. So that's in the book. But why would you want to learn them? Why would you go to the effort of reading the book or listening to this talk? So first of all, and maybe the most obvious, you will learn about different ways to solve a problem. So you'll expand your knowledge on how to deal with certain situations. But also probably if you read the book, you will find some patterns and you read about them and it feels like they're just common sense or good software design. Or maybe you already recognized the pattern, but you just didn't knew it had a name, it was a pattern. But still then, I think it's really relevant to know them, because it gives you also a shared vocabulary with other developers. You don't have to explain your whole solution. You can just say, yeah, I've used this pattern, and I've implemented in a certain way. And of course, it will still help to have a clear view of what the pattern actually is instead of your own way of seeing it. So that's why I think it's relevant to dive into them. But before we go to our supermarket, I need you to introduce to two people. The first one is Bobby, and you might know Bobby from Little Bobby Tables. I heard some yeses, that's good. So don't we skip the rest of the introduction of Bobby. And this is Bobby's friend, is Billy. Yeah, like that. And today we will follow Bobby and Billie. I don't know why I've chosen those names, because all the time I'm like having troubles with Bobby and Billie saying that too much behind each other. But okay. So on a Saturday afternoon, it's rainy and it's really cold. And Bobby and Billie are chilling on the couch, and they want to like watch a Netflix series. And they just turn on the television when they hear light footsteps on the hallway. And then the door's opening, and there's Bobby's little sister. She is 4 years old. She's cute and annoying at the same time. And she throws a note. The note she puts on the table in front of Bobby and Billie. And Bobby asks, like, what's that? She said, yeah, Mom gave it to me. But what's on the note? I don't know. She can't read yet, and Mommy hasn't told her what's on it. So Billie grabs the note, and she reads it, and it states, Bobby, please do groceries, and then a list of the groceries. So you might be wondering why I'm telling you about some Saturday afternoon of those two people. Because there will be design patterns in everything they do. So the situation we just saw, what was happening? So first of all, Mom wants her groceries, and she wants her son to get it. So she writes everything down on a note, what she wants and who she wants to do it. Then she asks her daughter to bring it to the table. And in the end, Bobby knows what to do with it. He knows how to handle the request on the note. So this is what we just saw in the situation. So which pattern fits with it? It's the command pattern. So in the command pattern, the most important concept is the encapsulation of a request. So in this case, the groceries, doing groceries, is encapsulated on the note. So everything about the request, who needs to do it, Bobby, and what's need to happen, all the groceries, is on that note. And by doing that, you can decouple it. So in this case, Mom doesn't have to go to Bobby. She can give it to the sister, and she doesn't have to worry when it's executed. She's decoupling the trigger from the content. And that little sister, she doesn't need to know what the request is. So she doesn't need to know what's on that note. She just puts it on the table, knowing that it will then be executed. So this is the pattern in more visual way. And the text on top is more like the terms using in the design pattern. And inside the blocks is the example we had. So we see that Mom, like that could be a client, she knows everything and she creates the request, which will be a command. So in this case, it's the note. So the note is an interface. And the little sister, Mom tells her, okay, I want to have this note set, like this command needs a set. Sister only needs to know it is a note, and she can execute a note. That it is actually, the implementation is a do groceries note, doesn't matter for her. She only knows this is her task. And then on that note, also the receiver is included. So in this case, Bobby, who needs to handle the request. And then Bobby knows how to deal with that request and how to handle it. So let's also see some code. And this code is not working code. There's no constructors. Some initializations are not done, but it's just to give you an idea. So you'll see that mom knows the most. So she knows the receiver, she knows the invoker, and she will create that node object, like the command, with all the information. So on the right, we'll see the details about that object. So the node, just the interface with an execute. The do groceries ones know about the grocery list and the receiver. And then the sister, she just executes it. And what I put in the comments is that she can chooses the moment of execution. So the mom doesn't worry anymore about it. It's just the sister who handles it. And right now she chooses to do it directly, but maybe she was playing with her dolls first. And then in the end, Bobby will be called to do the actually groceries. So, but yeah, Bobby and Billie were really not happy with this request, of course, because they were chilling, but they knew better than to argue with mom, so they just went to go to the supermarket, and they went to the vegetables department, to the cheese, and then they were halfway their list, and they couldn't find the coffee. Like the whole shelf was empty. And when they were there and looking for the coffee, they also heard other customers also looking for the coffee. So apparently no one can live without coffee, and they really needed it, and they were all complaining. And then they saw this employee, and they were asking him, okay, where's the coffee? When will it be back? And then when they asked it, all the other customers were also gathering around saying like, yeah, we also want to know. And then he was really grumpy, because all day people were asking him about coffee, and he had no clue when the coffee would be back in stock. So he said like, yeah, I've no clue. But then he thought about something. He created a list, and he said, please write down your email address and your name on this list, and I will let you know as soon as the coffee is back in stock. So that's what Bobby and Billie did. So what did we saw happening here? Bobby were asking the employee when the coffee was back in stock. But the employee didn't know. And he was so tired of everyone asking him the same question all over and over again. So he decided to create this list, and he would automatically notify everyone when it is back in stock. So this is the pattern, what we call the observer pattern. And the observer pattern is always about the one-to-many relationship. So in this case, we have the supermarket or the product, and we have all the customers who are observers and want to know about that product. Because they want to know about the state. If the state changes, they want to know it, and they will be automatically updated. And this gives you a lot of loose coupling, which makes it easier to change, for example, observers without that object needing to know. As long as the observers keep that interface, as long as they do like at least have that method that the object is expecting, then they can do whatever they want after they're called. And it's also really easy to have new observers. So this is how it looks in the scheme. First of all, we have the stock update, so the subject that has the state that the others are interested in, this guy's the supermarket. And the first step is that the observers, they have to register themselves. They have to know that they're interested in a certain state change. And then from outside, so that's not in the pattern, often you will see a lot of things that are not included in the pattern because they're really focused. So somehow they get updated. And what then happens, they automatically notify the observers. So there's just a list of observers and it gets notified because all the observers have the same interface. So they all have the update method and they can just call it. And then the observers can choose for themselves what they want to do in that update method. Do they go directly to the supermarket, or maybe they write it on their to-do list? That's up to them, as long as they have that update method. So let's see it in the code. We see on the right we have the interface observer with the update. So as long as the customer implements that, it's just fine. And then the stock update class, there's a list with observers. And to get on that list, observers can register themselves, but also relevant, they can remove themselves from the list. If they already bought the product in a different supermarket, for example, they don't need notifications anymore. And then there's the notify observers method that will just go over all of the observers and let them know the product is back. So they wrote their names on that list and they got to the next project on their list. But that was also a challenge. So they wanted nice cookies, and Billie saw these great looking cookies, but she's a vegan, and she wanted to know if the cookies were vegan. So she just turned around the package and looked at the ingredient list. But it was in Spanish. And Billie can't read Spanish, she can't talk Spanish, she just knows adios and gracias, and that's it. So she has a bit of a problem how to know if she can have those ingredients, the cookies. But luckily it's 2023 and there's something like a smartphone with the translation app, and she holds it in front of the product. She uses the live function and she could just see everything translated to English directly. And she was super happy because it was vegan. So what did we see in this pattern? So first of all, Billie wants to read the ingredients of the cookies, but it's in Spanish and she can't read Spanish. So she uses this translation app to do it to English, and she can read English. So she's happy to now be able to read it. So this is what we call the adapter pattern. In the adapter pattern, you see that two classes that normally could not work together are able to work together via that in the adapter. So the interfaces are not compatible. So in this case, Billie expects an interface that delivers English, but the interface of the product is in Spanish. And then the adapter plays the roles in between to convert them. And you can use it in this way to convert it in some way that you can use it. But you can also use this pattern to make a more generic interface. For example, think about you using a library in your code. Maybe that library does something really specific, and you might not want to have all the library-specific code through your whole application. Because what if you will change the library? Then you have to change your whole code base to make that fit. And then it can help to put the adapter in between. And you will make a more generic interface, just for what your application needs instead of the specific implementation details of that library. And in that case, it can help because it's way easier to change your library afterwards. So that's also a use case for this pattern. So, but back to our example, this is how it would look like in our scheme. And we see that Billie is the client, and she has something, what we would call the client interface, like what she would expect from the product. And she just expects it in English. I mean, she speaks English, she thinks the whole world speaks English, so she expects it in English. But the product interface is in Spanish. So then we put the adapter in between, which is the translator. And the translator had to make sure that they in the end connect, so it has to do in this case the literal translation. So in code, you will see we have the product, which is the interface. So this is what Billie expects, that she can just call get ingredients. Then we have the Spanish product, but it has get ingredients in Spanish. So now we have to have the translator, which is the adapter, to make this work. And, doesn't mean to do that. And then Billie, she can just say product get ingredients. So in this example, Billie, of course, knew that she was using her phone. She knew she was using an adapter to translate the Spanish text into English. But it doesn't have to be that way. So in your code, the client does not need to know about the adapter. It can be, but doesn't have to be. because you have, for example, here, Billy will just use the get ingredients on product and doesn't need to know that behind that there's a whole translation happening. So she has her cookies, and that brings them to the end of their list. So the last item is bread, and they go to the supermarket inside the bakery. So they go to the counter and they order bread. And what they get is sliced whole grain bread. And Billy and Bobby are not that happy about it because the crust is not crispy and it looks okay for like grilled cheese sandwiches, but not for the weekends where she wants the nice bread. So, but Billy has an idea. She knows this really good place, and they go out of the supermarket, and next door is this French bakery. So they get in, and they go to the counter, and they ask again for bread, because they have no clue about all the different French bread, so they just say, "Can we have bread?" And then the lady says, "Bien sûr," and she gives them a baguette. And that was way better. So it was so crispy and smelled delicious, and they were really happy with it. So what we saw happening was Bobby and Billie first go to the supermarket bakery and they order bread. Next, they go to the French bakery and they order bread. So they order the same thing twice, but they get different variants of the bread based on the location. So what's the pattern called? It's the factory method pattern. And this pattern is about you define in the superclass the interface for the creation. So what kind of object you're creating and that you're creating it. But then the subclasses do the actual creation, and they can also change the subtype. So in this way, it's easy to extend. You can create new creator classes. And that's also what we see here, how it works. First of all, on the right, we have the bread interface with the whole grain sliced bread and the baguette. Then we have the bakery. It's an abstract class and has create bread, also an abstract method. And that is the factory method. So that's what we call the factory method. And it states that you have to return the bread interface. And then the subclasses, they have to implement that method. They do the actual creation, and they can change the subclass. So the supermarket bakery will return the whole grain sliced bread, and the French bakery the baguette. And they still comply with the interface that they have to return bread. So in our code, you see we have the interface bread, and it just has the bake method. And then we have two implementations for the different kinds of bread. Then in our bakery, we see that there's a method that does some things and then also defines the create bread method. And then the two subclasses implement it, and they return the specific type, and they do the actual creation. So now they've smelled this delicious baguette, Billy and Bobby got really hungry. So they're thinking, okay, and they look at each other and they decide to order some sandwiches. So Bobby ordered a chicken sandwich and Billy one with vegetables. And they look when the baker prepares it. So they see that the baker follows a couple of steps. So even though the result is really different and the breads have different ingredients, a lot of the steps are the same. So the baker first cuts the bread, then puts a first layer, second layer, for the chicken sandwich also a topping, and then wraps some paper around it and gives it to the customer. And they're really enjoying their sandwiches. So what we see here is that Billy and Bobby ordered different sandwiches with different ingredients, but still the baker follows a certain process every time again. And most of the steps are the same, but steps can also be optional, like the topping for the chicken sandwich. So this is called the template method pattern. And what you do here is you define kind of a skeleton in the superclass. And there you say, what's the process, what are the steps? And then the specific implementation of those steps is in the subclass. But the superclass can also have an implementation. For example, if it's really generic, the cutting of the bread is so generic, it's for all the bread. You don't have to implement it by the subclass. And it can also have a default implementation, but I'll get to that later on. So here's how it looks in the scheme. You see that we have a sandwich, and it has the prepare method, and that's the template method. So in that method, it's a concrete method, everything is defined for the steps. And then some of the steps needs to be implemented by the subclasses. So then in this case, it's an abstract method at first layer, and it needs to be implemented by the subclasses. Because every sandwich needs a first layer, so you have to implement it if you're creating a new subclass. And in there you can make your difference. So the chicken sandwich, the first layer is chicken, and for the vegetable sandwich, it's hummus. So that's how you can make a difference. So in the code, we can see that this prepare has a lot of steps. So say, okay, prepare the bread, add the layers, topping, and wrap. So prepare the bread is just a method inside the superclass. And the same is for wrap, because they are the same. But then there are also abstract methods for the first and second layer, because you have to implement that as a superclass. There's no way that as a subclass, there's no way that the superclass can know about the ingredients for your specific sandwich. And that's also what we see on here, that the first layer and the second layer has to be described, same here. But then we also saw there's the add topping. The topping is only for the chicken sandwich. But if you declare it as an abstract method in your superclass, then all the different sandwiches have to implement that method even though they have no topping. So they all have to create it and then leave it empty. So that's why you also can say, okay, I make a default implementation here, and that's just no topping. So by default we do nothing. If you want a topping, you can override it. And that happens for the chicken sandwich. We add some sauce. So Billy and Bobby have their bellies full and their shopping bags full, and they head home. And they're so looking forward to finally chill on that couch. But then they come home, they drop the bags on the floor, and Mom is like, no. Please put away the groceries first, and then you can go relaxing. Billy and Bobby are rolling their eyes, but they know they should not argue, and they work on it. And 5 minutes later, everything is on the right place. So some of the groceries are in the fridge, in the freezer, also in the cabinet, in the pantry, everything is put in the right place. So what we saw is that Mom just says, put away the groceries. That's all she does. And then Bobby and Billy put everything in the correct place. And Mom does not need to know about all the steps that take, because she's only given that one instruction, and in the end they will put it in the right place, and she has no need to know about all the steps they have taken to do that. So for example, also all the groceries has to be filtered, like which parts are for the fridge, which are for the freezer, but also maybe they have to put in the pantry, they have to put the older products first and then the other ones. That are things that they have to do by themselves, and Mom just says, put them away. She's not going to give them all the specific details. So this is the facade pattern, and what's the most important thing here is that there's a simplified interface for the client. So the mom does not need to know about everything, she just knows put away the groceries. So that's the interface that you give to the client. And the subsystem behind, so in this case, for the subsystem, we will say all the different spots that the groceries can be stored. Mom doesn't need to know about it. And this removes a lot of complexity for the interface, because what if mom had to say, okay, I want you to put the milk in the fridge. I want you to put this, and I want you to do that, and I want you to filter on the date. That would be really complex and a lot of information for the client. So you'll store that in the facade. And in this case, the facade is Bobby. So see, you can also see it really like visual, that the facade is in front of all those objects, and the mom just has one point of contact and thing to know, which is Bobby. So she just say, okay, put them away. And then Bobby has the communication with all the objects in that subsystem, as they call it, below it. So in the code, I did not put all the objects of the subsystem, because it will be unreadable. But you see here really good that for the mom, it's easy. She knows the facade, and she just said, put away the groceries. And then for Bobby, and now it's even simplified, but normally it would also be all this filtering with belongs where, and then the right calls to the different place to store it, to have everything in the correct place and in the correct way. So all that complexity is not needed for mom anymore. And then we got to the end of all the different design patterns we're going to discuss today. And you might have seen that some of the patterns look really small. So you will need more to just use it in your code. So they focus on a certain part, and in the end, for a solution, you will use multiple design patterns. For example, when you look back at the bakery, we said, okay, so the different implementations, the French bakery, the supermarket bakery, they decide which kind of bread to return. They decide what to create. So you put that on that level. But then still you have the problem, where in your code do you define which bakery you're using? Because of course you can use the interface, but at some place you have to decide which subclass to use. So you still have to maybe use another pattern to decide in which situation do I need what subclass. And in this case, we saw that the client decides, because Bobby and Billie just choose which bakery to go to. But that you will see that often in your code, that the design pattern isn't like a solution for everything. You will use multiple to look at the bigger problem. But at least you know a couple of them, and if you're interested, you can read the book for more or use the internet. But let's review the ones that we saw. So first of all, we had the command pattern, which was mom giving a note to Bobby and Billie via her daughter. So the note is the encapsulation of the request, everything that mom wants. She puts in the note, and she then gives it, so everything is included on the note. And that's what you will do by the command. You encapsulate the request so that it's easy to pass it around and decouple the client from the actual execution. Then we had the observer with the grumpy employee who was asked over and over again about the coffee which wasn't in stock, and who decided like, okay, don't ask me, I will let you know as soon as it's available. So that's the idea of the observer, the one-to-many, and letting the dependencies know instead of ask you and all the time to go polling. The adapter was about the cookies, so the Spanish cookies that we saw, and the Spanish text needed to be converted to English. And you can use the adapter to connect to interfaces that would otherwise not be able to work with each other. The factory method was about the bakery, where the different subclasses, the different bakeries, create the objects and also decide which subclass to give back. Then we saw the template method with the sandwiches, that even though you have a completely different sandwich with different ingredients, the whole process looks alike. So you can use a superclass to structure it, so you don't have to define it all over again. So you will use the things that are the same, you will put them as high as possible in the superclass, and things that vary, that are different, put them in the subclasses. And then last was the facade, where mom was asking to put away the groceries, and she didn't need to know about all the details because that's handled by the facade. The facade will create a simplified interface for the client and will contain the logic from the underlying system. So for me, it helps to combine a more abstract idea like software architecture with something I can understand. So that's also why I created it like this, because when I was looking into design patterns and I Googled it, I read a couple of lines, were really abstract. I had already half an idea what I read, and then an hour later I forgot. So in this way, it helps me to remind it, and I will remind it better and understand it better. So if this also works for you, try to do this also with other design patterns or in general other stuff. Make it visual, make sketches, or just try to find an example that's either in the real world or in the coding world, but just make it easy for yourself to understand and remember. And if you like it like this, just send me a message if you have any design pattern you also want to convert to a supermarket scenario. I will try see what I can do. So the last thing is that I hope or hope not, I don't know, that if you go to the supermarket next time, that you will see the design patterns everywhere. And it will never be the same again. So I'm sorry for that. And I hope you will see more of them and find them everywhere. So thank you for your attention, and this is where you can find the slides.